All right, here's our review. It's kind of summing up everything we've done. So, what's the definition of a wave? A wave, by definition, is an energetic disturbance moving through medium. What factors affect the velocity of a wave? The properties of the medium only. If we want to do shorthand, it's just the medium, just what it moves through. If you change what the wave moves through, you change the velocity, and that's the only way to change the velocity of the wave. Describe a transverse wave. Medium moves at 90 degrees to the wave velocity. So if this is our medium and our disturbance is like this and it's moving down the medium that way, that's a transverse wave. If we have a long transverse wave, so we'll make it long. If we have a longer transverse wave, these are the easiest ones to see. The wavelength is from trough to trough or crest to crest, or the length of one entire wave. And then the amplitude is how high above or below the resting medium it is. Describe a longitudinal wave. In a longitudinal wave, what we get is the medium moves in the direction of velocity. And so let's say this is your medium. Imagine you have a slinky stretched out, and then you just push the slinky forward. What you get is this, you get everything's really, really close together, and then you get that piece moving all the way through. Everything's snapping back into place, but that compression moves all the way through. In fact, the way I like to talk about this one is a moving compression, which is what sound wave is. Sound wave is a longitudinal wave. What three possibilities can occur when a wave reaches the boundary between two mediums? Well, it can reflect. It can refract. And be absorbed. Reflecting is bouncing off the barrier. Refracting is transmitting through. And changing speed. And then being absorbed is being absorbed. Describe the principle of refraction. This is a wave changes speed as it changes medium. A magnifying glass is a great example of refraction. You have light coming into the magnifying glass, the lens, and then its direction changes because it's passing through the lens and it changes the direction that the light goes. Describe the principle of diffraction. So with diffraction, a wave changes direction as it goes around a barrier. Refraction happens when we go through something, Diffraction happens when we go around something. And so the wave was moving in this direction, and now the wave has sort of spread out. It's changed direction that way. Refraction and diffraction, they're both bending of waves. They're just two different ways to do it. What is pitch? Pitch is the frequency of sound wave. What factors determine the pitch of a plucked guitar string? Length of string, the length of string, the weight of the and the tension in the string. And the weight of the string is another way of saying the density of the string, or the diameter of the string, or whatever the string is made out of. Describe the principle of resonance. Basically, waves from one object make another object vibrate at the same frequency. Two tuning forks held next to each other are going to resonate if they're the same tuning fork. If you speak next to a stringed instrument, and if you hit the right pitch, what can happen is your sound waves from your voice box can make the stringed instrument hum a little bit. That's also resonance. Two students are making waves on a spring in a lab. They start shaking slow and easy, and then they make the following changes. What happens when they shake faster? So we get more frequency. You know what we're going to do? We're going to do a little table. We're going to do a little table, and it's going to be great. We're going to have the frequency. Nope, I guess we do wavelength first. We're going to do wavelength, frequency, velocity, and amplitude. So, if they shake faster, the frequency goes up, the velocity stays the same, the amplitude stays the same, and if the frequency goes up, the wavelength has to go down. Because our big principle here is that the wavelength is the velocity divided by the frequency. The velocity depends on the medium, the frequency depends on the source. So shaking faster is a source change. And then amplitude has to do with energy. Shake harder, that's an energy thing. So the amplitude, if they shake harder, is going to go up, but everything else remains the same. And if they stretch the spring out, that's a medium change. If there's a medium change, the velocity is going to go up. It's a stretched out spring. The frequency stays the same, the amplitude stays the same, and if the velocity goes up, the wavelength goes up. What is the Doppler effect? It's a change in frequency based on motion. A common example of a Doppler effect is the ambulance going by you, or a train whistle coming by you, and it's high pitched and it goes to low pitch. It's that wow. Car passing you does the same thing. Wave has a speed of 500 meters per second in air and a wavelength of 5 meters. What's the frequency of the wave? Well, velocity is frequency times wavelength. If I want the frequency, I'm going to divide both sides by the wavelength. So frequency is velocity divided by wavelength. So 500 meters per second divided by 5 meters gives me 100 hertz as the frequency. If the wave transmitted if it were transmitted into a medium where the speed is 1,000, find the new frequency and wavelength. Well, the frequency stays the same. So the frequency is still 100 hertz. That doesn't change at all. The speed is 1,000 meters per second. So the wavelength, as we wrote down at the top of the page, is the velocity divided by the frequency. So 1,000 meters per second divided by 100 hertz gives me a wavelength of 10 meters. That's the thing that changes. If it were transmitted into a medium where the wavelength is 2 meters, what's the frequency and the velocity? Again, the frequency never changes. It's still going to be 100 hertz. It cannot change because the source didn't change. Just the medium changed. And so the wavelength is now 2 meters. The velocity is the frequency times the wavelength. So 100 hertz times 2 meters gives me a velocity of 200 meters per second. Describe how a standing wave is formed. So we have two identical waves meet, so they are at the same place in a medium. And when that happens, we get that repeating constructive and destructive interference. And so it looks kind of like that. Now, if we want a specific one, to draw an example. So there's our standing wave. So the nodes are the places where we do not move a lot. 1, 2, 3, 4, 5 nodes. And then here, 1, 2, 3, 4, 5 antinodes. And that's our review.